At 6:47 in the morning on November 14th, 1930, an ore freighter cleared the mouth of the dredged Rouge River and began its slow push upstream toward the Ford docks at Dearborn, Michigan. She was loaded with iron ore from Ford's own mines in northern Minnesota. She would dock within the hour. Before the day was over, that ore would be charged into a blast furnace, reduced to molten iron, cast into engine blocks, machined to tolerance, assembled into running automobiles, and driven off a finished vehicle line, all without leaving the property. The River Rouge complex was not simply the largest factory in the world. It was a different kind of industrial idea entirely. Completed in 1928 after 11 years of construction, the Rouge measured 1.5 miles wide by 1 mile long, and it contained 93 buildings with nearly 16 million square feet of factory floor space, 100 miles of interior railroad track, served by 16 Ford-owned locomotives, connected every building. 120 miles of conveyors moved material between operations. 53,000 machine tools cut, stamped, drilled, and shaped. A power plant produced enough electricity to light a city the size of Detroit. A scheduled internal bus network ran on 15 miles of paved road inside the perimeter. At its peak in the late 1930s, more than 100,000 people went to work there every single day. Henry Ford called what he was building a continuous, non-stop process, from raw material to finished product, with no pause even for warehousing or storage. And every industrial civilization since has measured itself against what he built on the banks of the River Rouge. The Rouge was not an accident. It was a deliberate argument. Henry Ford's answer to a question no one had yet fully posed. What happens when a manufacturer controls every step of production, from the earth where the ore is dug to the road where the finished car is driven? Before we go further, if this kind of story matters to you, consider subscribing to the channel. Every video here is built around the systems that actually hold this country together. The power lines, the rail corridors, the infrastructure that most people never think about until it stops working. If that's the kind of documentation you want to keep watching, the subscribe button is how you tell us. And we want to hear from you. Did you work on a transmission line, a railway, a pipeline, a hydroelectric facility? Did a parent or grandparent spend their career maintaining infrastructure like this, keeping the lights on, keeping the freight moving? Leave it in the comments. These stories belong in this record. Now, back to the system. The Rouge worked because it was designed as a single machine rather than a collection of factories. Raw material entered at the ore docks. Iron ore and coal were unloaded by mechanical cranes and moved by internal rail to the coke ovens and blast furnaces. The blast furnaces, 5 of them at peak operation, charged ore, coke, and limestone together and reduced the mixture to molten iron at temperatures exceeding 2,800 degrees Fahrenheit. Each day, the furnaces produced more than 6,000 tons of iron. The molten iron moved immediately to the foundry, where it was cast into engine blocks, transmission housings, and other components. Excess iron went to the open hearth steel furnaces and was converted to steel for the stamping presses. The stamping plant cut and formed body panels from flat steel sheet. The glass plant, one of the few in the world operated by an automobile manufacturer, produced 500 tons of plate glass per day for windshields and windows. Nothing waited. The coke ovens produced byproducts, gases, tars, and chemical compounds that were recovered and processed in the byproduct plant into paints, fertilizers, and industrial chemicals sold to other manufacturers. A soybean conversion facility opened in the 1930s, processed Ford's own soybean crop into plastic components for the vehicles being assembled 3 buildings away. The energy to run all of it came from the Rouge's own power plant, generating capacity sufficient to light the city of Detroit. delivered through the complex's own transmission network. A car was completed every 49 seconds. 100,000 people in one place, every working day. The scale of the Rouge's workforce had no precedent in industrial history. To accommodate it, the facility maintained its own multi-station fire department, its own police force, its own fully staffed hospital. A maintenance crew of 5,000 men kept the machines running around the clock. Every month, 3,500 mop heads were replaced just to keep the factory floors clean. The men who worked the blast furnaces and the foundry operated in sustained heat that required mandatory rotation. The stamping press operators worked in organized stations, each one responsible for a precise task in a sequence that could not be interrupted. The assembly line workers moved with the line, the chassis, the body, the engine, the glass. Each station timed to the 49-second cycle that kept one vehicle rolling off the end per minute. Many of these men were recent immigrants. Polish, Italian, Hungarian, Arab, African-American workers who had come to Detroit seeking industrial wages. By the late 1930s, approximately 25% of the Rouge's workforce was black, concentrated in the hardest and most dangerous operations. The blast furnaces, the foundry floors, the coke ovens. Ford's $5 workday, introduced in 1914, had made Highland Park and later the Rouge magnets for labor. But the work was not kind. The line moved whether you were ready or not. The heat was relentless. The noise was constant. A foreman's watch governed every minute of the shift. They built it anyway, every 49 seconds. The Rouge was Henry Ford's property. Every element of it, the ore in the ground, the ore on the docks, the metal in the furnace, the car at the end of the line, reflected his conviction that dependency on outside suppliers, outside labor agreements, and outside sources of material was a form of weakness. To enforce that conviction inside the plant, Ford maintained the service department, a private security force under Harry Bennett that operated throughout the complex, monitoring workers, suppressing organizing activity, brainstorm, and maintaining a discipline enforced by physical intimidation. It was not a sustainable arrangement. On March 7, 1932, as the Depression deepened and mass layoffs stripped the Rouge of 25,000 jobs in a single year, between 3,000 and 5,000 unemployed former workers marched from Detroit toward the Rouge gates. Dearborn police and Ford security personnel fired on the crowd. 4 marchers were killed. Dozens were wounded. The event became known as the Ford Hunger March. On May 26, 1937, United Auto Workers organizers attempted to distribute Union leaflets on the Miller Road overpass above the Rouge gates. Ford's service department men attacked them in full view of journalists and photographers. The images of the beating circulated nationwide. The event became known as the Battle of the Overpass. The UAW was officially recognized by Ford on June 20, 1941. The last major American automaker to accept a union contract. What Ford had tried to prevent for 20 years arrived anyway. Not on his terms, but on the terms of the 100,000 men who had built his system for him. The Second World War brought the Rouge to its fullest operational capacity and, in doing so, revealed the outer limits of what vertical integration could accomplish. Employment at the complex peaked at approximately 120,000 workers during the war years. The assembly lines that had built automobiles were converted to produce military vehicles, jeeps, armored cars, and tank components. The foundries that cast engine blocks for the Model A now cast parts for military aircraft. Then the stamping presses that formed automobile body panels ran around the clock, forming armor plate and aircraft skins. Ford's massive power plant, the same one that had powered the civilian production lines, now supported a wartime production complex that operated on a scale no single manufacturer had previously achieved or would achieve again. A young Japanese engineer named Eiji Toyoda visited the Rouge in the early 1950s. He spent several weeks studying its machines, its production flows, its material handling systems. What he took home from Dearborn was not the model of the Rouge itself. The sheer scale was beyond replication, but a set of questions about what a more refined version of continuous flow manufacturing might look like without the waste, without the inventory, without the size. So, the system he and his colleagues developed in response became known as the Toyota production system. The Rouge had inspired its own replacement. The same forces that made the Rouge possible in 1928 began to work against it after 1945. The $5 workday had been a decisive advantage when Ford was building market share and needed to attract labor to a single, enormous facility. In the post-war era, with the UAW in place and wage rates rising industry-wide, the cost of concentrating 100,000 workers in one location became a structural liability. Every strike at the Rouge stopped every operation simultaneously. A wildcat stoppage at the stamping plant idled the foundry, the glass plant, and the assembly line within hours. The logic of concentration that had made the Rouge efficient also made it fragile. The Ford began decentralizing in the 1950s. New stamping plants opened in Ohio and Kentucky. Engine production moved to Cleveland. Transmission manufacturing relocated. The supply chain that Ford had built entirely inside the Rouge began to extend outward to independent suppliers, regional facilities, and eventually to the global sourcing networks that would define late 20th century automotive manufacturing. In 1989, Ford sold its steel operations at the Rouge entirely. The blast furnaces, the rolling mills, the open hearth furnaces, the original core of what Ford had built, passed to an independent company called Rouge Industries. The logic of vertical integration, which had seemed self-evident to Henry Ford in 1917, had become economically untenable. By 2018, the complex that had once employed 100,000 worked with approximately 6,000. What the River Rouge represented was not simply a factory. It was a proposition about control. The idea that if you could master every input, every process, every step from raw earth to finished product, you could eliminate the uncertainty that the industrial world ran on. Henry Ford was right about the efficiency. A continuous, uninterrupted flow of material from blast furnace to assembly line, with no external dependencies and no waiting, produced automobiles faster and cheaper than any system before it. At its peak, the Rouge rolled out 4,000 vehicles per day. No previous manufacturer had come close. But Ford was wrong about the permanence, the forces that vertical integration was designed to exclude. Labor's bargaining power, supplier independence, market shifts, did not disappear because he had chosen to internalize them. They waited. And when the balance of power shifted, as it always does, the concentration of everything inside one fence became a vulnerability rather than a strength. The Rouge still operates. The Dearborn truck plant, building Ford's F-150, sits on what was once the ore processing end of Ford's most ambitious industrial experiment. Trucks roll off the line today on the same ground where iron ore was charged into blast furnaces 90 years ago. The scale is different. The logic is different. What remains is the land, the river, and the fact that it was done here first. If this story gave you a clearer picture of what holds these systems together and what it takes when they come under pressure, subscribe to the channel. There are more corridors, more grids, more operations, and more decisions still to document. And if you have a connection to this kind of work, A relative who spent decades in a control room, a parent who worked a rail yard or a generating station, someone who was there when a system like this was tested. Tell us in the comments. What did they operate? Where did they work? What do you remember them saying about the job? The most complete record of how these systems were built and run isn't in any report. It's in the people who were actually there.